Hello again, welcome to another lesson in geometry. Today we're covering section 6-7, polygons in the coordinate plane. Okay, so we have some vocabulary here. Number one, draw a line from each item in column A to the corresponding part of the coordinate plane in column B. So instead of doing that, I'm going to draw over here and name them. So the center here is my origin. Okay. This green line that goes through the origin horizontal is the x-axis. Okay. The red line that goes through the origin vertically is my y-axis. And then everything over here to the right of the y-axis and above the x-axis, all of this stuff in here is quadrant 1. And then quadrant 2, same thing over here. Quadrant 3, similar over here. And quadrant 4, similar over here. Okay. All right. Vocabulary, classify. So definition, to classify is to organize by a category or type. Math usage, you can classify figures by their properties, which we've been doing a lot of for our quadrilaterals. Related words, classification is a noun and classified is an adjective. So example, rectangles, squares, and rhombuses are classified as parallelograms. Okay, so complete each statement with the correct word from the list. Use the word only once. Trapezoids are classified as quadrilaterals. So that's our adjective. Okay. Taxonomy is a system of classification in biology. That's a noun there, I think. Okay. And school children, or schools classify, and it's going to be our verb, children by the age. Okay. So we put them in different grade levels or different classes by their age. All right. Let's flip it over. Okay, on page 2, we have a key concept here, some review of some formulas on the coordinate plane that we learned. So we have the distance formula. This is tell how far it is between 2 points. Okay. We have the midpoint formula. This tells us the halfway place between 2 points. And we have the slope formula. This tells us the steepness of the line that goes between those 2 points. So when will we use the distance formula? We use the distance formula to decide if sides are congruent or if diagonals are congruent. This will help us for our polygons that are graphed on the coordinate plane. When will we use the midpoint formula? We determine if the coordinates of the midpoint of a side or whether diagonals bisect each other, because when they bisect, they split at the midpoint. Okay? And we use the slope formula to determine whether opposite sides are parallel, diagonals are perpendicular, or sides are perpendicular. So parallel, remember, this is going to give us the same slope, or diagonal, perpendicular, sides perpendicular, this is going to give us slopes that are opposite reciprocals. All right, so decide when to use each formula, right? D for distance formula, M for midpoint formula, or S for slope formula. So decide when to use each one. So you want to know whether the diagonals bisect each other. So bisect means we have to split things in 2 equal parts. So that's probably going to be the midpoint formula. So what are we supposed to do for that? M for midpoint formula. Okay. You want to find whether opposite sides of a quadrilateral are parallel. Well, determine if sides are parallel, we need to know the slopes of them. So this is going to be S for slope. And you want to know whether the sides of a polygon are congruent. To tell if they're congruent, we have to know the lengths of them. So this is going to be our distance formula. So D for distance. All right, so in our first example here, we want to determine whether we have a scalene, isosceles, or equilateral triangle. So this is going to be distance because we need to know the lengths of the sides of the triangle to determine what type of triangle it is, classified by its sides. So let's plot our points first. This is D at 0, 0. 1, 4 is E. 5, 2 is F. So if we connect them, it looks like this. And we want to know, what kind of triangle do we have? Isosceles, scalene, or equilateral? All right, so we need to find the length of EF. So the distance formula is the difference between the two x's plus the difference between the two y's, both of those squared, and then you do the square root. So the distance between the two x's for EF are 5 minus 1 and 2 minus 4. So 5 minus 1 is 4, and 4 squared is going to give us 16. 2 minus 4 is negative 2, and negative 2 squared is going to give us positive 4. And if we add that up, then we know the distance from E to F is the square root of 20. Okay? So the distance from D to E is going to be 1 minus 0. That's E's x's subtracted. And 4 minus 0. That's E's y's subtracted. Okay? Square both of those. So 1 squared is 1. 4 squared is 16. So the distance from D to E is going to be the square root of 17. So this is the square root of 17. So we know already, at best, we have an isosceles triangle. So let's find the distance from D to F. D to F is going to be 5 minus 0 and 2 minus 0, which will give us 25, and then plus 4, which is 29. So this is the square root of 29. Okay, so none of these are going to match. So what type of triangle do we have? Explain. So we have a scalene triangle. All sides have a different length. Okay, on page 3, we have problem number 2, classifying a parallelogram. So quadrilateral MNPQ has vertices of M at 0, 1, N at negative 1, 4, P at 2, 5, Q at 3, 2. Is this quadrilateral a rectangle? Explain. Okay, so we know it's a parallelogram. Okay, we just want to check if it's a rectangle. So the quickest way to do that is to just check if the diagonals are congruent. So we want to find the length of MP, because that's one of our diagonals, and the length of NQ, because that's our other diagonal. So MP, its length is going to be 2 minus 0 and 5 minus 1. Okay, so 2 minus 0 is 2. 2 squared makes 4. 5 minus 1 is 4, and 4 squared makes 16. And then you may combine them together to get the square root of 20. All right, so if the other one is 20 also, then we know that we have a rectangle. Our parallelogram will be a rectangle. So we want to do NQ. So Q's x is 3, N's x is negative 1. So that's 3 minus the negative 1. And then Q's y is 2 and N's y is 4. So 2 minus 4. 3 minus negative 1 is 4, and 4 squared makes 16. 2 minus 4 is negative 2, and negative 2 squared makes 4. So we have square root of 20 for both. So is this a rectangle? And this should be yes. This is a, so the parallelogram has congruent diagonals. Okay. All right, number 3, classify a quadrilateral. An isosceles trapezoid has vertices at 0, 0, 2, 4, 6, 4, and 8, 0. So this is an isosceles trapezoid because it has exactly one set of parallel lines. That's the top here and the bottom, and then the legs are congruent in length. Okay. So what special quadrilateral is formed by connecting the midpoints of the sides of A, B, C, D? So now we have to find the midpoints. All right, so to find the coordinates of the midpoint for each side, so we're going to do that here. We'll do AB with some steps to fill in. So remember, the midpoint is the sum of the x's divided by 2 and the sum of the y's divided by 2. So 0 plus 2 for the x coordinates makes 2, and 2 divided by 2 is 1. And 0 plus 4 for the y coordinates makes 4, and 4 divided by 2 is 2. So our midpoint, and let me erase my congruent marks here so we can do it a little better. Our midpoint is going to be at 1, 2. All right. So we have to find the midpoint of CD. So we add up the x coordinates, which are 6 plus 8 divided by 2. So the x coordinates of C and D are 6 and 8. And the y coordinates, which are 4 plus 0 divided by 2. When I'm done with that, I get 14 divided by 2, which is 7, and 4 divided by 2, which is 2. So 7, 2 is my next one. Okay. And then BC, this is going to be 2 plus 6 divided by 2, and 4 plus 4 divided by 2. So 8 divided by 2 is 4, and 8 divided by 2 is 4. So this one is at 4, 4. 4, 4 is right there. And then AD is going to be 0 plus 8 divided by 2, and 0 plus 0 divided by 2. So this will be at 4, 0. And that's right there. Okay. So draw the midpoints of the trapezoid and connect them all. So let me connect mine. And what does this new one look like, this new quadrilateral? I think it looks like a rhombus to me. Well, let's check. To verify your answer to extra 17, find the slopes of the segments, because to be a rhombus, the slopes of the segments, the opposite ones, should be parallel. So this could be a rhombus or a parallelogram. Not really certain which yet. Okay. All right. So first we're going to prove that it's a parallelogram by finding the slopes. So let's see. Verify your answer. Find the slopes of the segments from AB to BC. So I should probably put some of these vertices on here. So we had, see, A was at 0, 0, and B was at 2, 4, and C was at 6, 4, and D was at 8, 0. And we want to find the slopes of the connecting midpoints of AB and BC. So I have to find the slope of this one. And I need to also find the slope of CD, connecting midpoint to AD. So CD and AD. So those two red ones. And then we have to do the same thing with these two guys. ABs to ADs and BCs to CDs. Okay, and we'll check and see if those are parallel. So this will make it a parallelogram. So the slope of AB to BC, well, let's see. That is, I start here. I'm going to go 2 up and 1, 2, 3 over. So this is 2/3. Okay, and the other one over here, starting out here, we go 2 up and 3 over. So this one's also 2/3. All right, so we know that the red ones are parallel. And then the black ones, let's check that. They're going down 2 and right 3, so they're both negative 2/3. So since opposite sides are parallel, this means we have a parallelogram. So we've got halfway to a rhombus. Now we just need to show that they're the same length. Okay. So are the slopes of the opposite segments equal? This is going to be yes. Are the consecutive segments perpendicular to each other? So are the consecutive segments perpendicular? No, those definitely don't form right angles in there. So this is no. So we are not going to have a rectangle or a square. So the special quadrilateral is going to be what? Let's see. We're going to say rhombus. Okay. But we really should know that the sides are congruent to each other. And it doesn't say that on here. We didn't do the work for that. But if you just think about it for a second, all of them are up 2 and over 3 or down 2 and over 3. So they all go the same distance. They all go 2 up and down and 3 to the right. Okay, so they're all going to be congruent sides too. So this will make it a rhombus. All right, let's flip it over and take a look at our lesson check. Last lesson check of our chapter. So error analysis here, a student says the quadrilateral with vertices of 1, 2, so this is D, 0, 7, this is E, 5, 6, this is F, and 7, 0, this is G, is a rhombus because its diagonals are perpendicular. So let's see. So we've got this shape. And I'm going to say that's probably not a rhombus because the FG and DG look longer than the ED and EF. But there is another shape that has perpendicular diagonals, and we'll probably figure out what that is by the end here. So we've drawn DEFG on the coordinate plane. Underline the correct words to complete theorem 6-16. The diagonals of a, let's see, parallelogram are perpendicular. Then the parallelogram is a rhombus. So are our diagonals perpendicular? Okay, so let's check if the diagonal is perpendicular. So slope of DE, so we have the slope of DE is 7 minus 2 over 0 minus 1, which will give us -5. And then we have the slope of FG. FG is this one right here. And FG slope is 0 minus 6 over 7 minus 5, which gives us -3. And then we need to find DG slope. DG's in red here. So 0 minus 2 over top of 7 minus 1. This gives us -1/3. And then we need to find the slope of EF. So the slope of EF is 6 minus 7 over 5 minus 0. So that's -1/5. All right, so are both pairs of opposite sides parallel? I'm going to have to say no on that. So let me put my black one on here. I didn't do that. The black one was EF. So the red one and the black one are supposed to be parallel. They're not. They're -1/3 and -1/5, so the slopes are different. And the blue one and the green one are supposed to be parallel, and they're not. They have different slopes also. So are both pairs of opposite sides parallel? So this is no. So our shape is not even a parallelogram. And that's why it can't be a rhombus, because remember, a rhombus is always going to be a parallelogram with 4 sides congruent, which then makes the diagonals be perpendicular. So find the slopes of diagonal DF. So let's find the slope of DF. So DF would be 6 minus 2 over top of 5 minus 1. So the change in the y's for D and F. So 2 and 6 over the change in the x's, 5 and 1. So this will give us 4 over 4, which is 1. And then we need to find the slope of EG. So the same thing, the change in the y's will be 0 minus 7 over the change in the x's, 7 minus 0. And this will be -1. So are the diagonals perpendicular? Well, this is yes. So where's the error that the student made? Okay, so the student just said, oh, look, the diagonals are perpendicular. These two diagonals do form right angles, so that must be a rhombus. It looks like a rhombus to me, but in actuality, this is not a parallelogram, it's a kite. So this is going to have perpendicular diagonals, but it can't be a rhombus. Okay, so although the shape had perpendicular diagonals, and maybe instead of shape we should put quadrilateral. So although the quadrilateral had perpendicular diagonals, it was not a parallelogram. So it can't be a rhombus. And what it really was is a kite. Okay? All right, so check off the vocabulary words that you understand. So you should be able to find the distance. This is not the first time we did that. You should be able to find midpoint. This is not the first time we've done that. And you should definitely be able to find slope. You've been doing that one for a long, long time. So rate how well you can classify quadrilaterals on the coordinate plane. And it really is based on how well you can classify quadrilaterals outside of the coordinate plane. So some of you have a bit more memorizing to do than others. And I will see you in class next time as we do our last practice.